Next up under materials is alternative cement. Not sure that's exactly how it is presented here. It's basically arguing for using fly ash from coal burning to save some of the CO2 emissions. We will see how that works. So the ranking by 2050 of this approach is number 36 with 6.69 gigatons of reduced CO2. First cost is estimated at minus $273.9 billion. So you start off with savings, reduction in cost, and data is too indefinite to be modeled as far as net savings are concerned. Cement has been around for a long time. From the Roman Empire, the Pantheon was a Roman temple commissioned during the consulship of Marcus Agrippa 2000 years ago and completed by Emperor Hadrian by 128 AD. After nearly 2 millennia, the dome remains the largest reinforced concrete dome in the world. What is more remarkable is that the concrete remains intact, strong and almost ageless. Standing in what is now a church, the oculus at the center of the dome rises 142 feet. 6 million people visit it every year. Apparently the use of volcanic ash is what made it survive underwater, and that current cement wouldn't last, this current concrete wouldn't last this long, apparently. I don't know the details. Annual CO2 emissions from cement in 2019, you can see the numbers here. China and India are going absolutely crazy with new buildings because of all the economic development and infrastructure, so they are obviously emitting a lot. They are producing a lot of cement and emitting 500 million to 1 billion tons of CO2. Maybe India is in the range of 100 to 500 million. And then there are other countries, rich countries, that are still having many buildings, infrastructures, and Brazil, Mexico, and some Middle Eastern countries, Russia and Southeastern countries, and so on, at various levels of emissions. Let's run through an infographic from Carbon Brief that I stole from the website. Reducing emissions from cement is the goal here. So what is cement? Cement is the basic ingredient of concrete, the most widely used construction material in the world. So concrete is mixed of crushed rocks and sand and so on, which is held together by cement. Around 8% of global CO2 emissions come from cement production. Typically, over half of cement CO2 emissions come from making clinker, one of its major components. Since this CO2 is released through a chemical reaction called calcination, it cannot be eliminated by changing fuel or increasing energy efficiency. So basically, limestone CaCO3 is blasted in a furnace, in a kiln, to remove carbon, which is converted to carbon dioxide and released. Carbon capture and sequestration is one idea, of course, but to get calcium oxide out of limestone, this process is calcination, which is very carbon emission heavy. Cement is made here, ground limestone and clay with the rotating kiln at 1400 plus degrees centigrade. Hot air is pumped in, and you get the clinker that's coming out here on the other side. And Portland method is the most common method, which we won't get into. It's often referred to as Portland clinker. How can emissions be reduced? So carbon capture and storage, as I said, emissions from cement kilns could be captured and stored. However, CCS technologies remain at the basic research and demonstration stages, and no effective scalable CCS has been applied for cement or clinker production yet. Alternative novel cements include development of clinker-free cements, which could significantly reduce emissions. Some firms developing these claim to up to 90% emissions reduction, while others say cements could even sequester carbon, so you can make them to absorb carbon CO2 from the atmosphere. So this is from Chatham House, reflected on Carbon Brief. There are clinker substitutions. A proportion of clinker can be replaced with other materials such as fly ash and blast furnace slag, but this reduction of emissions is barely 5%, and I don't think it crosses even 10% at any rate. Reduced use of cement in built environment, for example, by recycling or reusing concrete, or designing buildings to need less concrete. There are people who argue that steel could replace concrete and no need to use concrete, and so on and so forth, but no indication that concrete is going to be outmoded anytime soon. To look at some more numbers in addition to the map we looked at from our world in data, million tons of cement produced here. Obviously China dominates. India is up here as well. EU, US, Turkey, and then rest of the world combined to be more than these big individual producers. Corresponding to that, there are million tons of CO2. China going from 600 to 1400, so about 800 million tons, and India 100 or so million tons, and down the rest of the world is emitting almost 400 million tons of CO2 per year. So reductions of emissions out to 2050, various options are considered: thermal energy efficiency, fuel switching, reduction of clinker to cement ratio, and innovative cement technologies like including CCS, or carbon capture, and sequestration. These are other methods: RTS, 2DS, and B2DS here. So reduction in emissions required to reach 2DS. In this scenario, these are different scenarios considered. In this scenario, the sector will have to meet its target on energy efficiency, fuel switching, and clinker ratio, as well as deploy CCS at considerable scale. CCS in particular is currently lagging because no scalable technology really exists that is commercially viable in terms of dollar per ton of CO2 captured. But you can see the numbers: direct CO2 emissions in millions of tons of CO2 per year. Going out to 2050, thermal energy efficiency is in fact not making any dent. Fuel switching is removing a little. Reduction of clinker to cement ratio is adding a little, and the innovative technologies are estimated here to reduce, like, let's say about a few hundred million tons of CO2 per year. Shifting beyond 2DS will require transformative action on clinker substitution, novel cements, and CCS, as well as deploying an array of demand-side approaches beyond the sector to lower overall consumption. These also become more critical if CCS proves too challenging to scale. Right now we don't know that. So this is the B2DS beyond 2DS scenario. Okay, so in other words, right now the chances of reducing CO2 from cement production beyond a certain percentage doesn't seem too optimistic, even out to 2050. This is from International Energy Agency, looking at fossil fuel, non-renewable waste, and biomass and renewable waste for global thermal energy intensity and fuel consumption during clinker production. 2014 and 18 are shown here. Not much of a jump there in terms of gigajoules per ton of clinker production, but sustainable development scenarios for the future would require that fossil fuel still continues to be used, and there is some increase in both non-renewable waste and biomass and renewable waste. So again, not a very optimistic scenario for the future. So in summary, because fly ash is a byproduct of burning coal, each ton created is accompanied by 15 tons of carbon dioxide emissions. Using fly ash and cement can offset only 5% of those emissions. Even so, if 9% of cement production between 2020 and 2050 is a blended mix of conventional Portland cement and 45% fly ash, 6.7 gigatons of carbon dioxide emissions could be avoided by 2050. The production savings of 274 billion are largely a result of longer cement lifespan. Obviously, if you want to phase out coal, then fly ash supply is going to be an issue, and a lot of fly ash has been dumped into landfills, and mining for those is also considered as a possibility, but quality control on that is uncertain. Plus, digging it up and transporting it to sites of cement production may not really save much in terms of savings, let alone in terms of costs. So there is the story of alternative cement in any case.